Well, we should go ahead and get started. So this morning, we are going to talk about freeze protection and cold protection for tropical and subtropical fruit crops, primarily focusing on the systems and the strategies for growers in Miami-Dade County. And so I'm going to share my screen with you. And let me just go over here. Share the screen. Can you see the screen?
Coming up. Yes.
Great. Okay, and you can still see it. Okay, so I'm going to go ahead and get started. So as I mentioned, we're going to talk about freeze protection of tropical fruit crops in Florida. And the emphasis in this presentation will be on Miami-Dade County strategies. I have another presentation that will be given later this week, which will talk more and emphasize cold protection for tropical fruit crops outside of Miami-Dade County. And that's because there are differences in strategies and access to water and the volumes of water that would be required to protect trees. So that's why I separated these presentations. So what is the freeze potential for 21-22? We are entering a La Nina phase, which is typically, we have below normal precipitation. And you'll notice in that one figure here, the temperature figure, we do have a 50 to 60% mean chance of mean temperatures will be above normal. And this does not mean a freeze event will not occur. I can tell you that, for the past 10 years, our winters have been warmer than, let's say, the historical normal. Excuse me. But as I mentioned, if you read the information that I sent when we sent out the notice, if you look at the National Weather Service and NOAA, this information is from them, but they also do put in the caveat, we do have a potential of freezing temperatures, which did occur in 2010. I know that's a long time ago, but it still is possible. It's better to be prepared than not prepared for a potential freeze event. So this is the typical weather pattern for La Nina, which we are entering. And you can see where the jet stream is, quite to our north. And that's typical for a La Nina pattern. And typically we are drier and warmer during these events. And this is supposed to last on into February, March, April, actually. And drought conditions are predicted during January, actually. So here is a summary taken from NOAA. And you can see the November to April outlook, most likely outcome above normal temperatures, 1 to 3 degrees. The below precipitation below normal, storminess below normal, freeze near normal, 1 to 2 events per season. So you can see, even though we can have these warmer than quote unquote historical normal temperatures, potentially we could have freezing temperatures. And I'm not certainly hoping for them at all. I'm just trying to educate and warn people and prepare people in the event that we do get a freeze event. And this is some historical data. It's a 30-year period, and it just looks at the number of times that we have experienced at or below 32 degrees. And you'll notice even in Homestead, there were 40 events during this period. So it's sort of interesting that, even though we may be warm, there is a potential for freezing temperatures in this location, and it happened quite frequently. So this is just some cold tolerance of tropical fruit crops, and these are the estimated temperatures for freeze damage or death, and these are non-protected trees. In other words, we have not tried to protect the trees with water or with wraps or with covers or things like this. And so this is based on a very long history of observations of the tropical fruit crops in South Florida. And I mean, basically from Palm Beach County south, on what happened to trees, these different species after freezing events, and what the minimum temperatures were when freeze damage occurred. And so you can see things like avocados, it sort of depends on their genetic makeup. Bananas, once you hit 28 degrees, you can see you're getting injury and potentially death. Carambolas are also sensitive. Jackfruit, key limes, especially sensitive. And you'll see, lychee trees can go down to maybe mature trees, 24, 25. Young trees, it's a higher temperature because it has less of a canopy, less of a footprint, less of a potential for impeding the loss of heat from the canopy. You can see papayas, very susceptible once you get to 30 degrees or less, passion fruit or less. You're going to have some potential cold damage or death. In contrast, look at loquats. If they're dormant, they can go down to 10 degrees. So there's a large contrast between fruit crops in their tolerance to freezing temperatures. And these are, as I mentioned, unprotected trees. Pomelos, sapodillas can go down to about 26 degrees. Spanish lime, though, once you get below 32, you may start to see damage. Look at the sugar apples, 28 to 29 degrees. Young trees are even more susceptible, 30 degrees. So what are the factors affecting the susceptibility and the recovery of tropical fruit crops to damage? So there's the genetic predisposition, as we just saw previously. The different fruit crops have different genetic tolerance to cold or freezing temperatures. Also, your site selection and the elevation, the slope, how close you are to a lake or to the coast can also affect things. And I know that elevation sounds funny in Miami-Dade County, which is basically flat, but even a 6-inch difference can make a difference between cold damage or not cold damage with some of these tropical fruit crops. Also, the health of the tree. Healthy trees, all things being equal, healthy trees, vigorous trees are going to be able to withstand cold or freezing temperatures better than non-healthy trees. Also, the plant stage of growth. And what I mean by that is that if your trees are actively flushing, whether it's new leaves or shoots or flowers, they're going to be more susceptible to cold damage than if they are dormant or quiescent. In other words, not growing because the temperatures or it's dry out and the trees are not growing. So that's important. So if your trees are flushing, they're going to be more susceptible to cold damage. Also, tree age or size. So as I mentioned before, the larger the tree, the more tolerant it is to cold or freezing temperatures. The smaller trees, less so. And that's because of their canopy footprint. A large tree helps to hold in some of the heat coming out of the ground when we have freezing temperatures. And then there's also predisposing environmental stresses. So if your trees were drought stressed or flood stressed prior to a freezing stress, they're probably going to have more damage than if they had not been drought or flood stressed previously. Cultural practices. So high fertilizer rates. So if you're applying, high nitrogen content fertilizers and stimulating growth with fertilizers, that's going to put the plant into a stage where it's growing and is more susceptible to cold damage than if it is dormant. Pruning. Also, this is why we generally do not recommend pruning trees during the late fall and winter, because this opens up the canopy to the sky And basically you're allowing all the heat that's under that canopy to just go up into the sky. And it also stimulates new growth, which is more susceptible to cold or freezing temperatures than dormant growth, right? And also irrigation. So, if you're irrigating your trees, you may be too much, you may be stimulating a growth flush. So while you don't want your trees to go under drought stress, you do want to control the amount of irrigation you're giving. And in general, as the temperatures decrease during the fall and the winter, the need for irrigation decreases. Why? Because the trees are less active in transpiring when the temperatures are cooler than when it is warmer. So therefore, you don't need to irrigate as much because the tree is less active with its water uptake and water use. Also, another factor is the depth and the duration of cold temperatures. So how cold does it get? Is it going down to 24 degrees, 28 degrees, 32? So the warmer the freeze is, right, so to speak, the potential, less damage. Although if you're at 31 degrees for 14 hours, you could have substantial damage, even though you're only a degree below freezing, or you're even at 32, right? Whereas if you have even just a few hours at 24, 25, or 26, you could have substantial damage. So there's this depth, how cold it gets, and also how the duration of that cold. And then, of course, the number of freezing events. So do the trees experience just one freezing event, or do we have 2 nights of freezing, or up to 4 nights of freezing? And this has occurred in the past. So that also puts another wrinkle into how the trees react and may recover from a freezing event. So again, this is just going over this briefly. As I mentioned, genetic predisposition. So, papayas are much less cold tolerant than avocado trees in general. The site selection, as I mentioned, the elevation, the slope, the nearness to water, establishing, new groves. So you want to, in most cases, well, in all cases, try to select a new grove site that has less potential of experience a freezing event. And so generally inland, it gets colder, or the potential for freezing is greater if you have a grove that's inland as opposed to one that's adjacent to the coast or near the coast or near a lake, right? In Florida, it would be the south side or southeast or southwest side of the lake would be a better strategy than on the north or northeast or northwest side of the lake. As I mentioned, healthy trees withstand and recover better. Non-growing trees or dormant trees can withstand more cold in general. And again, larger trees are more tolerant than smaller trees. And I spoke about the predisposing environmental stresses. High fertilizer rates or the poor timing of fertilizer. This is why we don't recommend people put out, nitrogen or a lot of fertilizer that stimulates growth during the late fall and winter. You don't want to stimulate this new growth. And as I mentioned, fall and winter pruning can be a problem. And as I mentioned, if the trees are drought stressed before a freeze, this can be a problem for the trees, can cause more damage than it would have been if that had not been the case. And I mentioned depth and duration of the cold, short, deep freeze versus a long, moderate freeze. They both can be damaging or even kill trees. And as I mentioned, multiple freezing events, potential for more damage. Improper use of or the breakdown of the cold protection system, you have a potential for increased damage. So we're going to talk about some cold protection methods, but especially if you're using irrigation to protect your trees, if it's not used correctly, you can actually cause more damage than if you had not used it. So monitoring the weather, and I think you're all very familiar with this. There's lots of access to climate and weather information. NOAA is a common source of information on the weather, and I mentioned that at the beginning of the presentation. FAWN, which is the Florida Agricultural Weather Network. This is something you really should bookmark. There are many weather stations throughout the state, and you can literally see the temperatures move and change in real time throughout the state of Florida. This is a very useful website, especially during the winter for cold protection. I would recommend bookmarking that website and learning all the different tools that are available in that website. Of course, there are other methods for monitoring weather: radio, telephone, TV, the web, private services, your smartphone. But at the grove level, it's not a bad idea. We do this here, is to have some thermometers in shelters in your grove, especially placing these thermometers in a small shelter, properly built shelter, in what you think might be the cold spot in that grove, and a slight low spot. And there are differences throughout a grove in warmer areas and cooler areas. Usually the cooler areas are a little bit lower in elevation than the higher areas. Psychrometers, where you can get a feel for what the dew point is, and that can become important because the dew point temperature can give you sort of a first look at what is the potential for freezing temperatures. If your dew point is at 32, if the dew point is at 32 or below, or predicted to be 32 or below, that tells you there is a potential for reaching 32 or low. And that's sort of like, this is the low that's potential. Now, the dew point can change during the night. If dry air moves in, it can actually lower the dew point. So you could have a dew point of 33 or 32 degrees, and you think, okay, so I'm going to be okay. Come back a few hours later, and the dew point has changed to 25. And that's because dry air moved into the area and that dew point lowered. So you need to watch the dew points throughout the night. And then also there is automated weather station equipment that you can buy. And the other thing is to be out there looking visually at the sky and sensing the environment. Is looking at the wind directions, feeling the wind, feeling the temperatures. Really on a freeze night, it's great to look at your computer and monitor the weather and things like that. But you really need to be out at the grove, looking around, feeling the temperature, looking for the clouds, sensing with your own senses what's going on out there, because that's going to give you a good clue. It doesn't always show up on the internet that there are actually clouds moving in, or these wispy little clouds are moving off and the temperature is about to drop like a stone. So I would just, it would behoove you to be out and about at your grove during a freeze event, and then looking at the electronic weather predictions and the fawn, on your smartphone or something like that. So is freezing weather on the way? In general, we would recommend that people need to be alert from late November through March, and you really should be prepared by mid-November. Trying to prepare for a freeze the day before, the night of, or even a week before can be impossible if you've got to make equipment changes or testing equipment or things like that. So you want to prepare as early as possible so that you don't have a surprise the night of the freeze, or you have a breakdown, which can result in more damage during a freeze event. So things to look at is watching the jet stream pattern, moving cold air from the northwest of the US to the southeast. And that's why we showed you that that jet stream from NOAA. You need to be monitoring the jet stream, because if that jet stream dips down, it causes a potential for, it makes the potential for freezing weather to come south more likely as that jet stream moves south. So supposedly it's going to stay to our north this year, which is a good thing, but things can happen. And then also, is there a low pressure system over the southeast around the Carolinas and West Virginia? Because remember, these wind patterns move from high to low pressure. So if we've got this low pressure system by us, there is the potential for that jet stream and the cold air mass to move south. You also want to watch for a large Arctic high pressure system, these large cold air masses that can be to our northwest especially. Another thing to look for is watch for the snow cover over the Midwest and the central US. Snow cover does not allow for the daytime sunlight to warm things up. And so a cold air mass going over snow cover stays cold or much colder than if it was over open ground. And then also, is there a high pressure center just west of Minnesota? That seems to be something historically that we've seen. If there's a high pressure system there, it seems to enhance the potential for that cold air mass to funnel its way down to Florida. And also looking at it this way, is there a high pressure center west of Tallahassee? Again, indicating there's a potential for it to move down south. So this is just a graphic, is freezing weather on the way. And so I've put in there a jet stream that has dipped to the south and shown you that there is the center part of the country is snow covered. And there's this cold air mass that is could potentially move south to Florida. So this is some historical rules of thumb and what to watch for. Sort of gives you an indication of, potentially we could have some freezing weather. So in advance of a predicted cold weather, we experience one or more days when the temperature does not exceed 65 degrees. So it's a good idea to be really cognizant of the temperatures and the winds during the winter. So like I said, if they're predicting some freezing weather even to our north, if we are down here and we experience one or more days when the temperature doesn't reach 65, that's not a good sign. Or it's a sign that we could have freezing weather. Also, days when the temperature is at or below 60 degrees at 3 p.m. or earlier in the afternoon. So again, we're not reaching warm enough temperatures to keep us warm. So potentially we're setting ourselves up for some cold weather. Also, if we experience 2 or more days or nights of cold but non-freezing weather, especially if they're accompanied by wind, and this is very common on our way to a freezing event, where we've got several days where it's windy and it gets cold at night and may only be in the 40s or maybe even in the 50s at night. But what's happening is it's literally blowing all the heat that's in the environment away. And as I mentioned, the snow cover over the Northwest, Midwest, and the middle of the US is also an indication we could get cold. Also, if the forecast calls for low nighttime dew point temperatures below 30 degrees or less. So remember that dew point is an important temperature to look at. So if the dew point's at 30, it means we could definitely reach 30 degrees, okay? Other things to look for is a cold high pressure systems, which can move out of Canada to the south. And they cross the border usually anywhere from Montana to Wisconsin. And they usually take 2 to 4 days to reach us. So this gives you, a little bit of time to, okay, we got to get ready for this. We need to be watching this. Of course, your irrigation systems or whatever else you're going to use should already be in place, but this tells you that you really need to be on heightened alert. Also, if record low temperatures are reported for the Midwestern states, potentially that could allow a cold air mass to move over the US without it changing much or getting any warmer. If the low level winds are blowing from the northwest, typical during the winter. And also, of course, if Florida's predicted a predicted target of a cold high pressure system, definitely gives you a hint we could be experiencing freezing temperatures. So normally, when we do experience a freeze, we usually experience 2 nights of freezing weather. And usually the first night is an advective freeze, and I'm going to talk a little bit more about this. And the second night is a radiation freeze. However, both types of freezes can occur on the same night. And I'll talk a little bit more about those. One thing you can do is you can get a fair estimation of the lowest temperature can be gotten by subtracting 20 degrees off the air temperature taken at sunset. And also the predicted nighttime dew point low is a fair estimate of the lowest temperature we can reach. And as I mentioned before, that can change. So the dew point could be 32, 33. You think everything's okay. You wake up at 2 in the morning and the dew point has dropped to 25 and the temperature is dropping like a stone, as I mentioned. So you need to monitor that because it can change. Also, there is a website, and I have it down there. You can use this program to get a calculation or an estimation of what the potential cold temperatures are going to be on a given night. And so it gives you an estimate. It's not written in stone that, oh yeah, it said we're only going to get to 32. It could be off, right? It's just a tool. Okay, what's an advective freeze? Advective freezes are where large cold air masses bring freezing and sub-freezing temperatures to Florida. And they are characterized by windy conditions. And I'm sure you've all experienced that, where you're having very cold temperatures and it's really windy. There's no inversion layer of a warm layer above a cold area. The heat from all exposed objects is constantly removed by the winds. So it's just removing all that heat. And this is a difficult type of freeze to protect trees from because of that wind. And we'll talk more about that in a moment, but that's what an advective freeze is. So here, I'm just showing you some graphics. The heat from all objects is blown away by that wind, whether it's plants, buildings, soil, the ground. And so it's a windy freeze, you could call it. Radiation freeze, in contrast, and they happen when there is little or no cloud cover and little or no wind. And I'm sure you've all experienced that. You go out and the sky is completely clear, crisp. There's no wind, there's no clouds. And what happens then is heat from all the surfaces radiate to outer space. There's nothing to block the escape of the heat waves from the Earth's surface. If there's clouds, that heat will go up, hit the clouds, and bounce back towards Earth. But on a clear night, that's not what happens. It just radiates out into outer space. One thing that can happen on a radiation freeze is you can have a temperature inversion. And it can occur when you have warmer air, and it's usually 30 to 50 feet up into the sky from the ground, where you have a warmer area, a warmer layer of air, and it exists above this cold freezing layer that's along the ground. If there is a difference of at least 5 degrees between these layers, mixing them can raise the air temperature in a grove. And there are wind machines that are typically used to mix those layers. In other parts of the country out west, it's a common thing where they mix these inversion layers to raise the temperature near the ground. In Florida, you do see some wind machines up in the citrus area. It's not super common. We don't see wind machines down here, typically because the radiation freeze, we don't freeze often enough for most people to purchase one of these or multiple machines, because you would, depending on the size of the grove, you would need more than one machine. And you wouldn't use them very often because we haven't experienced freezes that often, at least in the past 10 years. And this is the way this is: clear sky, no wind, and you'll see just everything is, all the heat is just radiating up into outer space. And this is what I'm just talking about, these inversion layers. So you have a cold air mass below a warm air mass. And if there's a difference of about 5 degrees, you can mix them, and it can be mixed with a wind machine. And in some cases, in some parts of Florida, people have used helicopters to mix that warmer air with the colder air below and raise the temperature. And you see in this example, the cold air is at 24, the warm air is at 38. You mix it and it brings it up to about 34. And this is just an example. Although, you're not going to, put in a wind machine the night before, and you're certainly not going to get a helicopter to fly over your grove, by calling up that night, can you fly over my grove tonight? So those arrangements all have to be made way ahead of time. So what are some of the methods of cold protection? Oops, I want it to go back. Okay. There are passive methods. There are some passive methods. Site selection, as I mentioned, clean culture is another one where you don't have any grass or vegetation under the trees. That's not common here in Miami-Dade County. Most people have weeds or grass between the rows, even though under the tree it may have little vegetation. Site selection, as I mentioned, the closer you are to the coast or to the edge of a lake on the south side somewhere, the warmer it's going to be. The farther inland you are, the potential colder it could be. Other passive methods would be a pre-cold irrigation event that you can do, and we'll talk more about that. Soil banks, so those they're not useful here in Miami-Dade, whereas tree wraps are something that could be done for young trees. Tree covers are generally not practical and very labor intensive putting on and taking off. Some active methods, fuel heaters, not commonly used anymore. There's some environmental issues, especially with the old diesel fuel heaters. Irrigation is probably the most common way to try to protect trees from a freezing event. There are mist systems, although there's a lot of problems with using a mist system, which is a type of irrigation system, but it puts out super fine droplets and you're basically causing a mist, although that can be easily blown away by the wind, or if it gets clogged, then the system isn't really working. As I mentioned, wind machines, which are not commonly used here and expensive to install. Ditch flooding, there are some parts of Florida, not down here. People will use flood irrigation, filling the ditches between the rows with water. And then there's also combinations of using passive and active methods. So the pre-freeze irrigation. So water has a high capacity to store heat, fortunately. So irrigating a grove several days prior to a potential freeze event increases the soil's capacity to store and then re-radiate heat during a freezing event. But the key is it's got to be several days prior. The evening before the freeze, no, because you're wetting the soil, you're saturating the soil several days ahead of the freeze. The sun comes out, warms that water up that's in the ground and stores that heat, right? And then that heat can then be radiated up into the grove, into the trees during that cold event, which will help keep the grove a little bit warmer. Also, one thing you want to think about is that the greater the grove surface area that's irrigated, the greater the soil heat storing capacity. So if you're using drip, that's really not going to help much because the pattern, the spread of a drip irrigation system isn't very wide. So you're really not doing much. A micro sprinkler system, yeah. So some of them throw out water, 3 feet, 5 feet, 10 feet. The more, the better, because you're increasing the heat capacity of more of the soil, right? So irrigating during the daytime prior to the night of a predicted freeze is not recommended, especially if it is already cold or windy, right? If you're throwing water out into the environment and it's super windy, it's evaporating, and actually evaporatively cooling, you're probably removing more heat than doing any good because it's just too late. You don't have enough time for or sunlight hours for that water to be warmed up in the soil, for the soil to be warmed. So young trees, let's talk a little bit about young trees and tree wraps. And just to be clear, tree wraps only delay the heat loss around the trunk. They don't stop it, they delay it. So if the trunk would normally reach freezing temperatures, let's say after 2 hours, by putting the tree wrap on it, it might take 6 hours. Okay, so it's delaying that heat loss. And that's a good thing, because if the freezing event is only 2 hours long, and you have a tree wrap, and the tree wrap is good for, let's say, delaying heat loss down to 32 for 6 hours, you're going to make it through the night with little damage along that trunk, right? To be more effective for tropical and subtropical fruits, it probably should be used in conjunction with irrigation if it's appropriate. If it's windy, though, I wouldn't turn on the irrigation, but it can be used with irrigation to be more effective. However, these tree wraps need to be constructed of materials that have a high insulation value, such as fiberglass insulation, or there are some others. However, be warned, there are some tree wraps that are sold that are sort of like an egg carton-like material that you just sort of snap on around the tree. Actually, they don't really work. Actually, there's been recorded cooler temperatures under those wraps rather than warmer temperatures. So it's got to be something that has a high insulation value. They also need to be inspected periodically after you put them on, and possibly removed after the freeze event or after the winter. Why? You know, fire ants and other insects will set up house underneath those wraps and can cause damage to the trunk and the young trees. So they aren't maintenance free. Plus, it takes time to put them on, right? So trying to put on, 10,000 wraps the night of the freeze is just not going to work. It's got to be done because it takes time beforehand. So here's some examples: citrus, and you'll see a tree wrap around it. And then this is a sapodilla tree, and it has a fiberglass batting wrap around the base of the tree. And basically, as I mentioned, so it's delaying the heat loss from that trunk. So even if the top of the tree is killed, at least that trunk area and the scion is still alive, and the tree will regrow. And so that's one of the benefits. And on the tree on the right, you'll see that they have raised that micro sprinkler up into the canopy for additional cold protection. And the one on the left, they didn't, and you see the sprinkler is facing the tree wrap to encase it in water or ice to help add added protection. Okay. One of the problems we have with tropical fruits, not a problem, is that we don't have a lot of experience using micro sprinklers for cold protection like they do in citrus. And citrus is, in general, more cold hardy. Let's say oranges, things like that, mandarins, much more cold hardy than many of the tropical fruits. So here's this tree wrap I'm showing on the sapodilla, and there it is by itself, again, around the tree. So you get a feel for this is what it, and so what they had done was you can also take this fiberglass insulation and either just wrap it around and tie it like you see here. In some cases, I've seen people staple it to chicken wire so that they can attach it and take it off that way as well. So systems using water. So, oops, I don't know why it's doing that. So you have mist systems, which we don't recommend really. There's too many problems. Flood irrigation, which is not used here in Miami-Dade County. And then there are these various types of irrigation systems. And by the way, I should just mention in the chat, I've put the link to a number of publications on cold protection, including a publication on descriptions and uses of irrigation systems for tropical fruit crops in Florida. I would behoove you to read that. It gives a good description of the different types of irrigation systems and what they can be used for appropriately. So you'll see there's a number of high volume systems and then also micro irrigation systems. So first, what's the principles of cold protection with above ground irrigation systems. You know, how do they work? How does water work to protect a tree? Okay, so when the water comes out of the ground, the sensible heat or the inherent heat of that water coming out of the ground gives off a little bit of heat as it cools to 32. So it comes out of our ground, out of our water system, out of the aquifer here, 65, 68 degrees. And so when it goes from 65 to 32, it gives off a little bit of heat. And you would say, wow, it's really dropped a lot. It's got to give off a lot of heat. It doesn't. When it gives off a lot of heat is what we call the heat of solidification, also called the heat, heat of fusion. And what it is that when water changes, I'm sorry, let me just turn this on. When water changes from liquid to solid, it gives off a lot of heat. So that's how water protects a tree, is that when it changes from a liquid phase to a solid phase, it gives off a huge amount of heat. If sufficient water is continually applied to a plant, and if the plant can withstand 31 to 32 degrees, in other words, survive 31 to 32 degrees, the heat given off as the water changes from a liquid to a solid maintains that plant at 31, 32 degrees, and the plant lives. So you're basically entombing that plant in ice. And as long as you keep adding water that is freezing to that surface, you can keep that plant at 31 to 32. Okay? And that's how the plant could survive, if it can take 31 or 32 degrees. So there are three key components in place that need to be in place for an irrigation system to work in freeze protection. Number one, the plant has to be able to survive 31 or 32. If 31 or 32 degrees kills that plant, then it's not going to work or work well. You also have to apply sufficient water constantly to the surface or to the tree, to the surfaces of the tree, whether that's the trunk or the leaves or both, right? And it has to be continuously applied throughout the period of freezing temperatures, right? You don't want it, if the system can't do that, you run out of gas, you run out of diesel, you run out of electric power, that's going to be a problem. And also the water must completely cover the plant surfaces. And it's not always true for survival of some portion of the tree. And what I mean by that is that if you're sprinkling, if your irrigation system just hits the trunk, or let's say it just goes up to 3 or 4 feet into the canopy, and from the canopy 3 or 4 feet up down to the ground, it's protecting the tree with water. You may lose the top of the tree, but you'll save that lower part of the tree, right? So you have to have sufficient water, and that means we recommend at least 0.2 inches of water per acre per hour or more. So you've got to have a system that can put out sufficient water, and it has to cover the plant completely, or at least that portion of the tree from, let's say, 3 feet down completely. Why? Because if you're just getting parts of the tree wet or somewhat wet or misted, those parts are actually going to evaporatively cool, and they're really going to be damaged on those areas or killed. So high volume system, and I'll just, that publication I mentioned goes through this, the one on irrigation systems that I put into the chat. So take a look at that. I don't know whether I'm going to, read everything carefully here, but these high volume overtree systems aren't as common now in this area as they once were, but they're characterized by metal pipes that are up into the tree canopy. They're usually spaced 40 to 60 feet apart in the grove. They have a 60 to 100% overlapping spray pattern if you look at it from above with all the other sprinklers. The sprinkler heads make one complete rotation in a minute or less. You do need high pump pressures, 50, 65 pounds per square inch, and they'll apply 0.2 inches of water per acre per hour or more. You want to be sure the pump and the engine have the capacity to do that. And I can tell you the more water, the better, right? Because that's your heat source. Advantage, you're completely covering the land and the trees. They work well for many tree crops. They do have some disadvantages that you need high pump pressures for good water distribution. The maintenance to the irrigation head is essential. In other words, the heads can't be clogged, otherwise it's just not going to work. And it's also hard if during a freeze, one of the heads freezes up. You need to take that high volume irrigation system down while the system is running, unclogging it and put it back. So be prepared to get quite wet as you're doing that. Also, there is the possible wind distortion. So if it is somewhat windy, the pattern of the irrigation system can be distorted and reduce its use or its function or its ability to protect the tree. One of the other possibilities is that if we really have a deep freeze and a long freeze, you can get some ice buildup on the limbs and actually break the limbs down. You won't necessarily kill the tree, but you will certainly break the tree, the limbs and things, although you can split trees open. So here's a high volume system in a carambola grove. You can see the close-up of the head. Here is the high volume irrigation system in the carambola grove during a freeze. And you can see the carambola trees are willow-like anyway and pretty flexible. That entire tree is covered in ice. And that tree survived. Those trees survived fine. After a significant freezing event, I should mention. Here's high volume in sugar apple grove, and you can see the entire tree is covered in ice, and those trees came through fine. And you can see the sprinkler running in that top photo. Here it is close up. Here's high volume irrigation. That longan tree, you can see it just split the tree open. So you can, and the Miami grove, it lost limbs. So you can have ice buildup and then some significant crop damage. But you know, for the most part, it worked pretty well. There's also high volume under tree, and these are much more common now. They're either metal or PVC piping, and they're topped with a high volume nozzle, a rainbird type nozzle usually, or a spinner type. You do have to have more sprinklers per acre than you do with the high volume over tree. So you need to have them spaced so there's no more than 2 trees between each sprinkler, either each row or every other row. If it has spinner types, usually it's 1 sprinkler per tree. Again, you need good overlap with sprinkling. It'll apply water anywhere, 3 to 5 feet up into the canopy. So as I mentioned before, there is a potential to lose some of the canopy up above but you'll save most of or a good part of the canopy. Again, you need relatively high pressure pump. They need to make the sprinkler heads need to make a complete rotation in a minute or less, or if it's spinners, that's you don't have to worry about that. And again, applying 0.2 or more inches of water per acre per hour. Again, advantages: complete land cover. One of the other advantages is that there is potential wind distortion of the irrigation pattern is less than with the high volume over the tree system, right? So this is inside, closer to the ground, is being protected. The wind is less strong inside the grove, so there's less potential distortion. Also potential for less ice loading, right? I already mentioned protecting trees, maybe not all the way up to the top of the canopy. There is a possible for incomplete coverage of the trees due to the interference of the pattern by trees, by adjacent trees. And you do need more irrigation laterals and heads per acre to get good coverage and good cold protection. And this is showing you high volume under tree systems here, lychee on the left and guava being used. And you can see the bottom of the trees are covered in water. In-tree systems, these are not common. There are a few people that have had them or have them. And this is where you have one riser or sprinkler is required for each tree. And they're usually placed 3 to 8 feet within the tree canopy. And they're applying 2 to 3 gallons of water per minute per tree throughout the canopy from the inside out. They require a pump pressure, somewhere, generally 40 to 50 PSI. They're either spinner types or rainbird types. And they're putting out much, much more water. You need a bigger pump and a bigger engine to make this system really effective, although this system will really protect trees from freezing temperatures very, very well. But it's expensive, and you have to have bigger, better pumps and engines. Advantage: you're only covering the canopy surface area. There's little wind distortion, so you don't have to worry about the wind as much as you do with these other systems, the wind distorting the pattern. Usually less potential for limb breakage or limb ice buildup because there's so much water being put out, you may not even get ice buildup. Disadvantage: higher initial investment, high volumes of water. Again, depending on how big your trees are, if your sprinklers are only at 7 feet, it may only protect the tree from 7, 8 feet down, right? But most of the tree would survive. This is just showing you a tree where the rest of the canopy had been exposed, and you see the sprinkler there. The one on the right, you can see it's at about a 5-foot height, and it's a spinner type. And again, another type of system are these low volume micro sprinkler systems, and generally applying between 10 and 30 gallons per sprinkler per hour or more. There are some micro sprinklers which actually put out more than 30 gallons per sprinkler per hour. It's recommended at least 2,000 gallons per acre per hour rate. They use polyethylene tubing for the laterals along the soil surface, and they use hard plastic spray heads. The pump pressure is less, 30 PSI. These ground-based systems have been used successfully to protect citrus and sapodilla. The micro sprinkler in-tree systems have been used to protect citrus up to 5 years old during calm freeze, maybe even trees that are 10 to 15 feet were protected to about 8 feet. But remember, I was telling you, we have very little experience using these to protect tropical and subtropical fruit crops, which are more cold sensitive, less freeze tolerant than oranges, mandarins, many of the citrus, right? So if you're going to put your micro sprinkler out, you want to place that micro sprinkler on the northwest side of the tree. Why? Because during freeze events, most of the time, the wind is coming out of the northwest. And you want that spray pattern to be pushed onto the tree, not away from the tree. If you have it on the south or southeast side, and the wind's coming from the northwest, it's just going to push the sprinkler, the water is not going to reach the tree. Also, many of the microjets have, 180 to a 360 or 270 degree pattern, right? A spoke pattern or a spray pattern. It would be more effective to put on a 90-degree spray pattern where you are directing it directly at the trunk or the lower canopy of the tree. But that would mean, changing sprinkler heads on a lot of trees. So you might think about that. If you're going to use a micro sprinkler, place 2 to 3 feet up into the tree canopy along the trunk. That's one way, and use a 360 or a 270 pattern. That's one way to increase some of the cold protection up into the canopy somewhat. And in this case, rather than using the 90-degree pattern, spray pattern, you use the 360 pattern. Some of the advantages: less pumping size and capacity is needed. You're using a lower volume of water per acre. It may be easier to maintain and repair than a high volume system. As I mentioned, disadvantages: if it's really windy, you can get wind distortion of this micro sprinkler system. When you apply less water, you have less potential cold protection as well, right? And as I mentioned, the citrus is more cold hardy, and that we have limited experience with tropical fruits in this. And I see a lot of new groves going in without people thinking too much about the potential for protecting the trees from cold. So you need to be thinking about this as we move into our winter periods. So here's a lychee tree up on the left with a ground-based system. And on the bottom, some citrus that used a ground-based system. And you see the ice around the trunk of the tree, and those trees have wraps. And so that tree wrap plus the micro sprinkler has protected that tree. And obviously the canopy on these trees came through the cold event fine. If it had damaged that canopy, more than likely you'd start already to see damage on the leaves. On the right is this sapodilla system that was used during a freeze event with up into the canopy with tree wraps. And that was in 2010, the last time we really had a freeze event. So there are some crops with special issues. You know, pitaya, its tolerance to chilling and freezing temperatures is species and clone dependent, and we are not real familiar with just how cold tolerant they are. We do know they're sensitive to chilling injury, which are temperatures at 41 degrees or less. And we'll talk a little bit about photo damage, the bleaching of the epidermis, photo inhibition, which we have already seen and experienced. In the literature, when you look, that there is potential for damage of dragon fruit or pitaya at 29 degrees or less, and that you can get damage or death of the plants at 24 to 26 degrees. So considerations: irrigation, high volume system, is that what you want to use? There's overhead systems, and I do see some overhead systems in some of the dragon fruit plantings. Is there a potential for ice buildup and breaking down the stems? Probably, but you might protect and save most of the plant. Potentially with an under the plant system, you know, spraying up, you know, 3 or 4 feet, you could protect, you know, along the pole, 3, 4, 5 feet of the vine. You might lose the top of the vine. We don't know how effective micro sprinklers would be. You might, and I have seen in a few cases where people have put plastic stem barriers at the base of the plant to prevent water from hitting the stem directly. And then also high insulation wraps at the base of the post. That may also help. We don't know. And then also the pre-freeze and the immediate post-freeze whitewashing of the sky exposed stems. So we'll talk a little bit about this photo damage or chilling injury and the potential to avoid that damage from cold temperatures. So pitaya damage, we call it photo inhibition. So basically what's happening is the exposed surfaces of the pitaya vine, when it gets cool out and we have high light intensity during the day, the vine, the photosynthetic system has trouble functioning normally. And so sunlight hits it. And normally it would be absorbed, some of the light would be absorbed, some would be reflected off of it, and some of it would be used to later on drive photosynthesis or carbon assimilation. However, when it's cool, that system can't work fast enough. And so the high light, instead of that heat, instead of that sunlight being absorbed for photosynthesis for later on, actually causes damage. So it actually affects the photosystem that does photosynthesis, and you end up with this bronzing or yellowing of the leaf. And so you're actually seeing damage caused, we call it sunburn, caused by high light and cool temperatures. And that can happen even with chilling temperatures. So temperatures above freezing, but let's say below 45 degrees. So this is what I was saying before. Let me just go back. Is that if we get into a situation where we're having cool, chilling type temperatures during the winter, whether, and we've not tried this, although it makes sense that this may work, is that by applying a whitewash, which can be made either, you can either buy hydrated or slaked lime with a little bit of zinc sulfate, and you spray that out over the vine. And you don't have to get the undersurfaces of the vine, just the over the top part of the vine. And it's basically going to reflect that extra sunlight or heat off of the vine. And you would have, protecting it from being photo inhibition or cold damage or sunburn. Or you could use white latex paint and mix it 50-50 or 60-40 with water and spraying that out over the vines. Either prior to getting into chilling temperatures or just when it starts, right? It's not going to cure chilling temperatures afterward. You've got to do it, during or after, during or before the chilling temperatures are experienced. Passion fruit. So, cold tolerance is species and hybrid dependent. Generally tolerates 40 to 55 degrees. Hybrids, not sure. They can tolerate some brief exposures to frost. Maybe down to 28 if it's very, very short, the purple types. Considerations, high volume irrigation. So you do see some overhead systems out there, and those do work. You could get some stem damage or vine damage, but they do work if they're used properly. Under plant damage, again, you could lose parts of the vine, but perhaps save the bottom of the vines. We're not sure how effective micro sprinklers could be. Again, plastic stem barriers at the base of the plant to prevent water hitting the stems directly. As you know, there's a lot of fungal diseases of passion fruit. So irrigating for 12 hours could be a problem, whereas if you put insulation wraps at the base, potentially this might help in addition to the irrigation or by itself. Here's passion fruit, and here's a high volume over vine system, and you see the vine encased in ice. This planting went through a freeze in 2010 and survived. Bananas, another one. Below 68, it slows its growth. 50 to 57, the growth basically stops. Chilling injury begins, 51 to 55 degrees, and you end up with different types of damage. Below 32, freeze damage, potential plant death. You can also get frost damage even at 32 to 34 degrees. So considerations, success of the freeze protection, varies. Plants killed to the ground generally regrow from that underground corm in the ground. So you might just have to remove all the above ground pseudostems or stems after a freeze if they look like they're declining or freeze damage severely. And just remember, generally it takes at least 4 healthy leaves are required to mature a young banana bunch. So if you don't have any leaves or just one leaf, it's probably not going to mature that bunch. A nearly mature bunch may mature after leaf death, perhaps. A newly emerged or 50% developed bunch will not mature. And you want to wait to see how many functional leaves you have on the mature plants before you decide what to do. So here's banana after a freeze event, the one on the left, basically a total loss of everything above ground. On the right, you can see there was an attempt at some cold protection. The leaves are covered in ice. They were still damaged. On the bottom left, you see a fruit that looks sort of gray now, and that's because that fruit has been damaged by the cold. So it will never be a quality fruit. Papaya is another one. You know, you get below 68, it slows down, gets below 54, and it basically stops growing. And it begins to experience chilling injury and other types of damage. Once it gets below 30 degrees, you're looking at freeze damage, plant death, things like that. Irrigation with papaya, if it's overhead, if you get ice buildup, you're going to break the leaves down. Under plant irrigation, probably less damage. The amount of damage may also be affected by the height of the plants, right? You know, if you're only able to protect it up to 3 or 4 feet, you may lose the top of the plant, although cutting off that top part, if it's damaged, it may go ahead and branch out, and you can get fruit production off the branches, and then may be useful for this pre-freeze irrigation. And this is just showing you, this is a high volume under tree system being used to protect these papayas, and they did come through this freezing event quite well. Oh, sorry, that didn't work. Okay, so how to prepare for a freeze event. Install a cold protection system, and you need to maintain it. You need to test it. And you should test it periodically throughout the cold season. If you're using diesel or gas, you want to keep the fuel tank as full as possible during the fall and winter. Why? Because calling up to call for gas or diesel a day or two or the night of a freeze, you may not get the fuel. We would suggest you purchase 1 or more Grove thermometers and build these little shelters. You'll get a true picture of the temperature, and you can see that one on the left. We have temperatures monitored at about a 6-foot and a 2-foot height. And that's important in the sense that if you have young trees, it could be 32, 33 degrees at 6 feet, but actually 28 or 24 degrees at 2 feet. And then after a freeze, you come back and you think, oh boy, the trees came through fine. And then a few days later, they start to die. And what has happened is that the freezing temperatures experienced at the base of the tree actually killed that tissue around the trunk. And now the tree can't take up water. And so it becomes drought stressed and dies. You do want to either have some way to listening to the weather or looking at the weather on your smartphone. It is a good idea to have some temperature gauges out there. And it is also, if you can buy digital psychrometers now that tell you sort of what the dew point is out there, actually in your grove, not at a weather station, but actually what's happening in your grove. So what happens if a freeze is predicted? So you want to be closely monitoring both the predictions and what's occurring. And remember, I talked about those, days of not reaching 60 degrees or several nights where it's 65 or less and it's windy, right? And you got to remember, most of the weather forecasts are for urban areas. Most of these National Weather Service temperature gauges are located at airports or in urban areas. Now, the Fawn station here in Miami here is located at the research center, and we have it out in a 10-acre field that the only thing it has is grass. So you're getting a much better feel for what the temperatures are, right? But again, you do want to monitor your grove as well. It could be different than what is happening here at the research center. I would also listen or look at more than one weather source to get a feel for what the temperatures might be or are. Testing your system. Remember the pre-freeze irrigation grove floor several days ahead. That means you need to be monitoring and paying attention to the weather during the winter to know, well, oh, actually, it looks like there's a prediction for freezing weather in the next 5 days. Okay, so now is the time to do that pre-freeze irrigation, not the night before, not the day before, but days before. So The other thing you want to watch out for is temperatures dropping very rapidly, 4 to 10 degrees in about 1 to 2 hours, into the 30s within an hour to several hours right after sunset. And usually in the winter, that is between 5:30 and 6 p.m. And this does occur occasionally and has caught people off guard. Everything looks like, we may have a freeze that night, and you're prepared and everything. And so you're going to rest for a while in the evening and get up at 2 and check the weather and things like that. But you need to be watching the dew points. So if the dew point during the day is in the 40s or 32 or below, and the relative humidity is low, and you have clear skies during daylight hours prior to that nighttime freeze event that may occur. When the sun goes down at sunset, that temperature can drop like a stone. As I mentioned, it can drop 4 to 10 degrees in 1 to 2 hours. And then all of a sudden you realize it's 12 o'clock and the temperature is at 32. So you really need to pay attention to the dew points, because that's telling, and the relative humidity, it's telling you, hey, it's dry, the dew point's low, and as soon as sunset happens, you're going to start to see that temperature drop really rapidly. So you need to pay attention. Okay, so it's freeze time, and assuming you are properly prepared, when do you start your high volume irrigation system if you have one? Okay. If the wind speeds are 10 miles an hour or less, if your pump and engine has a clutch, or the engine has a clutch, you can turn the system on and idle it at 3 to 5 degrees above freezing, right? Just in preparation. However, you want to actually turn it on full blast when it's about 35 to 36 degrees. And once this system is on, you do not want to turn it off until the air temperatures are at or above 40 degrees or above the wet bulb temperature the next morning, which is above 32, right? However, if the wind speeds are above 10 miles an hour, even though this is a high volume system, if it's an overhead system, you may want to wait until the wind dies down. And it may even be better not to irrigate. Why? If you have a high volume over tree system and it's really windy, that advective freeze, what can happen is you get this wind distortion of the irrigation. So your trees are just getting sort of misted rather than covered in water. And you're actually evaporatively cooling, and the tree temperatures are actually going to go below freezing. So it may be better to just wait. And you may have to wait until 2, 3, 4 in the morning when the wind dies and it becomes clear, and then turn that system on, right? If you have a high volume under tree or in tree system, as I described before, you may be able to turn those on because they're inside the grove. They're being protected by the canopy of the trees. And so they're not going to get that wind distortion, or is not as much. And I'm talking about mature groves, not a young grove where the trees aren't really impeding the wind movement. I'm talking about large full canopy trees, so a mature grove, or a grove with mature trees. Okay, micro irrigation systems. This is where it gets trickier. You really, and this is why I was telling you, you want to monitor. So most of the weather services, they give you the temperatures at 6 feet. The fawn system gives you temperatures at 2 feet, 6 feet, and 30 feet. And this is another reason why you want to monitor these lower elevation, lower height temperatures. Remember, your micro irrigation system, the irrigation lines are on the ground. And you want to monitor those lower air temperatures because that's where your tree trunk and where your trees are. They're small trees. If the winds are 5 miles an hour or more, not recommended you turn on the system, because there's a high potential for distorting the pattern of the irrigation and getting evaporative cooling, which makes the tree colder. If the wind is 5 miles an hour or less, you could start irrigating prior to 32 when it's about 35 to 37 degrees. And partly you want to turn on this irrigation too, is because you want to prevent the water in the polytubes, which are on the ground surface, from freezing. So you might even have that system on just as a trickle, just to keep the water flowing. Because, you know, if all of a sudden you decide to turn the system on and it's frozen in the lines, it's not going to work. Okay, so you need to be monitoring these cold temperatures, especially to use these micro irrigation systems, and paying attention to the wind and the capabilities of your system. If your system can only put out 10 gallons an hour per sprinkler, you're probably not going to be able to use it, except for cold protection during the freeze. You can do the pre-freeze irrigation, but during the event, probably not. So it's freeze time. So monitor the temperatures, be looking. This is why I'm saying you need to be outside occasionally, looking at the cloud cover. When clouds move over, that's a good thing, because it prevents heat from completely going to outer space. It hits the cloud surface and bounces back, helping to keep things a little bit warmer. You want to listen to the weather forecast, and it does change throughout the night. As I mentioned, dew points change throughout the night. You might start out with a dew point at 35, and then at 2 o'clock in the morning, it's at 28. So you need to be there. You also want to pay attention to the direction of the wind. So if it's coming from the north and northwest, and you're getting this cold air mass moving through, but if the wind direction changes and it starts coming in from the east or the southeast, it's probably going to warm things up, right? Because it's coming out from the bay or the ocean. You also want to monitor and be walking around the grove or driving around the grove looking for clogged or broken sprinklers, and be prepared to fix them immediately. And as I mentioned, so many times our freezing weather comes in twos. In other words, 2 nights of freezing weather. So again, you need, you want to be prepared with parts and things like that. Again, a lot of different things, a lot of different sites for monitoring the weather and looking at predictions. The National Weather Service has a lot of good information, as does NOAA. The agroclimate website is also really good. It has some prediction tools and things like that. So there's a lot of information out there. It's a good idea to familiarize yourself with those. I know myself, I usually set up my computer to be looking at least 3 or 4 sites as I'm monitoring the weather throughout the night, besides going outside and actually looking and feeling the weather. IntelliCast is another one. Weather Underground is another one. The Fawn, this is the one I would suggest you also have bookmarked. And it has tools on it as well. I'd familiarize yourself with those prior to getting too far into the winter. Miami-Dade County also has some weather sites that you can monitor in real time. So I would key into those and bookmark those. I know I do. The Homestead General Airport really doesn't provide online temperatures. They do have a phone number. I don't know if, to tell you the truth, that one's working right now. The Homestead Air Reserve Base, also you can get some weather from them. It's a little difficult to get, but there is some temperature data there. Remember, that's to our east, so it's really along the coast. It's going to be warmer there than it is inland, even here in Homestead. Some common freeze damage, plant symptoms. Let's talk a little bit about what happens, what to look for after a freeze. So with leaves, you could get wilting, water soaking, where the leaves look sort of dark and maybe even starting to turn brown and die. One thing to look at is that, and this would be the next day or so after the freeze, is if the dead leaves persistently hang on the stems of the tree. So we've had the freezing event, things have warmed up, the next day, next couple of days. if the leaves on the tree are hanging on the tree and they're dead or dying, that indicates there is some stem damage. And I'm not saying do anything about it, but that you could say, you know I have some stem damage or some limb damage. If the leaves immediately start dropping off, that means that that tissue on the stems was alive enough to actually separate from the leaves and drop off. So you probably have less damage. Again, flowers and fruit, if it's water soaked, if the fruit looks water soaked or brown or shriveling or dropping off, obviously you've got damage. Here's some leaves. These are avocado leaves, and you can see they've already started to turn brown, and that's water soaking. The carambola on the right, those leaves are desiccating, drying out. They were damaged. The carambola on the bottom left, you'll see it's lost a lot of leaves and fruit. And there's definitely some leaves hanging on, so there's some stem damage. The carambola fruit on the right, look at the pulp of the fruit near the fingers there, and you can see they're water soaked. So even though the fruit was on the tree, there is freeze damage. I already showed you this longan tree where the limbs got loaded with ice and it split the tree to the ground. The bananas you also saw where the tops, all those pseudostems were killed. Really the best thing to do is just go in and chop all those off and lay them down as mulch, so the new pseudostems can come out from the underground stem. So common freeze damage, again, some other ones, twig, limb, and trunk discoloration. That can indicate, if you pull the bark back a little bit and see that it's browning, that means there's some damage, water soaking. You can have death of some of the wood. The trunk area and the major limbs, bark splitting is a sign of cold damage. Exuding sap, again, and of course, obviously, death of the stem or the shoots. So, post-freeze trees care. Trees with no visible twig or limb damage. Let me just say, the best thing to do after a freeze event with respect to pruning is do not prune immediately after a freeze event. Why? And I know everybody's anxious, especially if you see dead leaves and some dead stems or dead leaves. People want to get out there and do something to recover these trees right away. Best thing to do is don't do anything to the tree. You cannot tell what is entirely dead at this time. And if you do start pruning, you may be pruning off live wood. So you don't want to do that. Again, another thing is that there may be another freeze event. And even dead leaves will help provide some barrier to heat loss from the ground up into the sky. So the best thing to do after a freeze is don't do any pruning, right? And again, if you do prune, you may not remove all the dead wood, and then you have to go back later and prune out the dead wood. So, and it may take 2 to 6 months to know what is actually dead. So it's going to take a while to see. And then once you see what it actually is dead, then prune it back to live wood. Okay, so I know everybody's anxious to do something after a freeze. The best thing is to just wait. And when you do prune, you want to, prune the jagged limbs. If it's total, prune it back to live wood is basically. You could spray copper onto the entire tree at labeled rates one time, maybe to tamp down some fungal rot. We don't recommend painting the cut surfaces. First of all, if you have a whole lot of cut surfaces, that's way too much labor. And also those pruning paints and things like that, generally not necessary to do. So irrigation post-freeze. Okay, so if your trees have little leaf damage, if it came through fine, they should be just irrigated normally like you do during dry periods. If you have moderate leaf damage, so you have less of a canopy, so let's say you've lost 25% of your leaves, right? You want to reduce the rate and frequency of your irrigations. Why? Because remember, the only way for a tree to lose water is through its leaves. If you had 100 leaves, normally that's a higher rate of water loss or water uptake than if you now only have 75 leaves. You see what I mean? So in groves where they have little or no leaves, they really shouldn't be irrigated until you see signs of new growth. Why? Remember, leaves, in order for a tree to take up water and nutrients, it has to have leaves. If you're irrigating a grove or trees that have no leaves, you are super saturating the soil and you're suffocating the roots with a lack of oxygen. And the tree may actually decline and then really die back. Okay, so you want to be watching very closely and don't irrigate trees that don't have leaves. Once they start to grow, then you can irrigate a little bit. But by irrigating or irrigating too much, you're not going to make the tree grow faster. So you have to watch it and just be judicious about how much you're going to irrigate. Fertilization. Okay. If you have had little leaf or wood damage, you would just normally go back to your fertilizer, whatever, whether it's conventional or organic. If you have moderate leaf loss, you may want to fertilize the trees frequently, but at a reduced rate. Why? Because as that tree is reestablishing canopy, it's going to take, it'll start taking up more and more nutrients, but you don't want to give it a big shot of fertilizer, especially you could end up actually causing a salinity problem, too high a rate. If you have complete loss, once the leaves start to come back, you can fertilize frequently at slightly higher rates as that new growth comes on, because it's going to be trying to recover that canopy. If you have severe loss, so you have canopy damage, loss of the canopy, you want to reduce the rate of fertilizer in proportion to the canopy loss. So if you lost 50% of your canopy, reduce the rate at the beginning to 50% until it starts recovering, right? Weeds also do need to be, generally need to be controlled after a freeze, because they can compete for water and nutrients, and in some cases light, with the trees. I haven't seen this myself, read about it, heard about it. Weeds can be a fire hazard if they're all dead and they happen to have very dry conditions. I've not seen that, but it is something you might consider. So my recommendation is people be ready by mid-November. You want to monitor the weather nationally, regionally, locally, and in your grove. And, best of luck. As I mentioned, I have one other thing too, in the chat. Let me go back here. Okay, so I'm going to stop sharing for a second. So in the chat, as I mentioned, I put a post-seminar evaluation form. If you click on that link, I would really appreciate if you would go to that evaluation form and fill in the evaluation. It's 13 questions, but they're very easy answered. I'm not asking you to do a lot of typing. I'm asking you to just click on some things for the most part. It'd be greatly appreciated. And as I mentioned, there are 4 other handouts there, or links to handouts that you may find of value later on. And with that, I'm open to some questions. Jeff, are you there?
Yes, sir.
You heard everything?
Yeah. Jonathan, I'm going to repost the links because if people came in later, they wouldn't see. I'm just going to copy and paste.
Great. Thank you. Thank you.
So,
So,
Jonathan,
hi.
thank you so much. It was really informative. And I was wondering the same thing. It seems like the chat doesn't have any information at this time.
Okay.
I had a question related to mangoes. Do you have any recommendations for mangoes in particular? Uh, are the temperature tolerance levels about the same as some of the other trees that you spoke about today, or?
Yeah, so they, it tends, let me, sorry, let me get this, sorry, let me pull this up. Yeah, so on mango. So if you, yeah, actually, boy, I see I missed putting mango in there. Yeah, mango, I would say, is similar to the lychee, maybe a little bit less so, somewhere between lychee and mamey. So, historically, it's been similar to those two crops. So you're looking at, for a mature tree, being able to, and I'm talking about without cold protection, and I'm talking about a mature tree with a full canopy, somewhere 26, 27 degrees, you could see damage on a mature tree. And it depends on the duration. Remember, I was saying, so you could be at 32 for 12 hours, could be just as damaging as 24 degrees at 2 hours. You see what I mean? So I would say the mango is similar to those two. And let me just look at here and make sure. Yeah, so mature trees, mango, about 25 degrees is when you would start to see damage on the tree or potentially kill a tree. Young trees, somewhere between 29 and 30 degrees, you'd start to see damage. So yes, I would say, yeah. Mhm.
The other question I had was, we have a few trees in our backyard, and we have a sprinkler system that's, watering the grass. Do you think that helps against the cold as well?
Okay, so yeah, that system is really not going to work to protect your tree from freezing. The best it could do is you could do, well, in fact, the trees are surrounded by lawn, I take it.
Yes.
Yeah. So, you could do the pre-freeze irrigation. It will help a little bit, but having said that, one of the issues with having grass or weeds is that in general, it's harder for the sun to heat that water up in the soil than if it was bare ground. Okay. So having said that, though, it would be worth, let's say we're going to have a freeze in 5 days, it would be worth sprinkling your yard real well 3 or 4 days ahead of time and just leaving it at that. But running it during the night to try to help the tree is not going to work. In fact, if you did that and the tree is just sort of getting misty, wet, it's going to actually get colder than freezing and cause a lot of damage to the tree. So about the only strategy you have is potentially the pre-freeze irrigation. If you want to wrap the trunks of the trees with an insulation material, that will help slow the loss of heat. So instead of taking, let's say only 4 hours to reach freezing, it might take 6 hours, right? And if all of a sudden sunrise comes before the 6 hours is up, you've made it through the freeze. You see what I mean? So,
Got it.
and with those wraps, though, remember they have to be good insulation value, something like the fiberglass wraps or batting, and they need to be taken on and off. You can't just leave them on forever. You'll end up with the trunk might stay too wet. As I mentioned, you might get ant colonies living in the wrap, which is not a good thing either.
Great. Thanks a lot, Jonathan.
Sure, my pleasure. So, Jeff reposted those links. Hopefully you can see them now, and I would appreciate the evaluation form being filled out. So, we have recorded this, so we will post the recording and send that out. So people, if they want to look at this later on, if you're trying to fall asleep and if you want to look at something that'll put you to sleep, you could watch this. Are there any other questions? If not, I am going to stop here and thank everybody for attending, and hopefully this will be useful. Thanks, Jeff.
Thank you, Jonathan.
Talk to you later.
Okay, bye.